Dear all, welcome to my channel OA level mathematics. Today's our topic is about trigonometric ratios. As we know that there is a right angle triangle where we have a right angle triangle and there are two angles which are acute angles. Now let's list the names of the lengths of this triangle. So we have this is the perpendicular, the vertical height, and this is the base, which is the horizontal, and this is the hypotenuse. We all know about the Pythagoras theorem, which says that c square is equal to a square plus b square, where c is the hypotenuse, a is the perpendicular, and b is the base. Let's talk about the ratios corresponding to the angle theta. So first ratio is known as sine theta, which can be defined as perpendicular over the hypotenuse. The second ratio, which is known as cos theta, cos of theta is defined as to be base over the hypotenuse. The third ratio, which is defined as to be tangent theta, is defined to be perpendicular over the base. Let's write them in terms of the defined lengths. So perpendicular is A over C is the sine theta. The cos theta would be B over C, and the tan theta would be A over B. It is to be noticed that we can write the tan theta in terms of sine theta and cos theta, which is as sine theta over the cos theta. How? So let's look at this. A over C and E over C. So if we simplify this, this will become A over B, which is the tan theta. We oftenly forgot these ratios, and there is a sneaky way to remember these. So you need to remember this sentence. Some people have curly brown hair through proper brushing. Let me explain how. So some means this S means sine would be equal to P for perpendicular, H for the hypotenuse. Similarly, C for cos is equal to base over hypotenuse. And the last one, as you know that, is the tan would be equal to perpendicular over the base. So in this way we can remember these ratios. Now let's look at some example. We have right angle triangle over here, which have this length is 3, this length is 4, and this length is 5. So there's a question. So use Use the Pythagoras theorem to verify this time. Okay, let's get back to our example. We need to find a ratio which comes out to be theta for sine. Sine theta would be equal to perpendicular over hypotenuse. Now let's list the hypotenuse, which is over here, is opposite to the right angle triangle, and the perpendicular would be the opposite to theta, and base would be adjacent to theta. So this is b is equal to 4, p is equal to 3, and hypotenuse is equal to 5. So the sine theta ratio becomes 3 over 5. The second ratio, cos theta, would be equivalent to base over hypotenuse. So we can write 4 and 5. The third ratio would be equal to tan theta, which is equivalent to perpendicular over base, which is equal to 3 over 4. So these are the three ratios.